Okay, this video is on accuracy and precision in measurements. We're going to be talking about the difference between accuracy and precision, even though they seem almost like synonyms. And then we're going to be talking about the idea of error in measurements and what that means and how we can calculate a few things associated with that. So if you think of the word accuracy and the definition of accuracy, you might have a lot of things come to mind. So the true definition of the word accuracy is how close a measured value is to the actual value. Okay, so we're talking about two terms here, and those two terms are the measured value and then the actual value. So probably the easiest idea of accuracy that I can give you from a non-chemistry standpoint or even a non-science standpoint is talking about grading, okay? So like when you take a test. So if you take a test, of course, if you want to think about, what is the actual value on a test? Well, it would be the number of points that are possible, right? And so you are trying to obtain as many points as you can. So let's say you have a test that's worth 100 points and you get a 98, right? A 98 out of 100. Okay, so you know that the 100 is the actual value, while the 98, I know it's not really measured here because you earned that score, but that would be what would fall into the place as the measured value. And so if you had to gauge your accuracy on this test, how close were you to that actual value of 100? I would say you were pretty close. So the term here would be that you were very accurate with a 98% or a 98 out of 100, which of course is a 98%. On the other hand, if a different student took that test and they got a 54 out of 100, right? I think you could argue that in this case they're not very accurate, or the accuracy would be very poor. Okay. However you would want to describe that. So let me clear my screen and let's do a kind of chemistry example, or let's do a science example. Okay, let's say you find a thermometer in your lab drawer and you're curious as to whether or not it's working very well. Okay, so you take it outside and you leave it sit for the entire morning, let's say. And while you're letting that thermometer sit outside, you look up the temperature outside on the Weather Channel. And so let's say the Weather Channel says, now I'm going to work in Fahrenheit here, which we're going to learn very quickly we don't work with, but for now it's okay. Let's say that the Weather Channel says it's, 76 degrees Fahrenheit outside, okay? And so after several hours of leaving your thermometer outside, you take it out and you read it. And let's say it says, 74.5 degrees Fahrenheit. And you would have to make a judgment call on whether or not this thermometer is accurate, okay, based on those two numbers. So in this case, this value would be, the measured value, right, because you were measuring it with your thermometer, while we're trusting that the Weather Channel is the actual or true or real value in this case. So if you had to make a judgment call, I would say that thermometer is pretty accurate. It's going to give you a pretty decent idea of what the temperature of something is. Okay, so versus, let's say that you find a second thermometer, okay, and the Weather Channel still says it's 76 degrees outside, and you take that second thermometer outside and you leave it for, several hours. And that second thermometer comes up and says that it is, 46 degrees outside. I would hope that you would be able to make a judgment call that says that this thermometer is not accurate. And I would hope that you would not use that thermometer in any of your experimentation once we have confirmed that it is not very accurate, okay? So when we're talking about accuracy, we're discussing how close a number is to a measured, how close a measured value, is to a actual value, okay? And that's the basis of the word accuracy. Now, in a different discussion, we're going to talk about the word precision. So what does the word precision mean, or precise? Okay, if you're accurate, it means you're close to the real value. Well, then what does precision or precise mean? So this is one that often throws students for a little bit of a loop until the definition is given to you. And so the definition of precision is how close several measurements are to each other. Notice there's no mention of an actual value, okay? So let's say that you and some classmates are measuring the mass of something, okay, using a balance. And one student says it weighs 2.10 grams, another student says it weighs 2.14 grams, and the third student's balance says it weighs 2.11 grams, okay? Now, we have no idea what this thing actually weighs, but in this case, it doesn't matter because we're only looking at precision, how close several measurements are to each other. So you have to make a judgment call on, are these three values pretty close to each other? And in this case, the answer is yes, they're very close. So this set of data would be precise. And actually, for that matter, I would say it would be very precise, right? Those numbers are very similar. Versus if you had three different students and three different balances weighing the same object, and they got 2.10, 4.25, and 7.89 grams, right? In this case, how close are these values to each other? Oh, not very. And so this data would be not precise. Okay, notice on this discussion of precision, we haven't mentioned what the actual value is at all, okay? Because in this case, we don't even know it. And in this case, precision, well, in all cases, precision has nothing to do with what the actual value is, okay? So one thing I like to do with accuracy and precision is talking about like a target, like you're throwing darts. Oops. Okay, because this is a visual, and I think it's pretty helpful. Okay, so let's say you're throwing darts, and of course, when you throw darts, the goal is to hit the bullseye in the center, right? So let's say there's, I don't know, we'll at least do three of these. There's three targets, and there's three people throwing darts, right? And here's your red bullseye in the center, okay? And here, I'll change my color. So let's say, let's do this. Let me ask you to do this. Let's try to draw a target that shows somebody throwing darts who is precise but not accurate. Okay, what would that look like? Precise but not accurate. So think about that for a minute, or just a couple seconds, and see if you could put some darts on your target to represent somebody throwing darts who has good precision but poor or bad accuracy. And then I'll come up with a couple other things in just a second. So what would it look like if your dart throwing skills were precise but not accurate? Well, so again, if we're not accurate, we're not hitting the bullseye, right? But if we're precise, that means our darts are hitting relatively close together on all of my trials. So for example, maybe this would be precise but not accurate, right? Think about it. All four of those darts are pretty close together, yet none of them are close to the bullseye. So precise but not accurate. All right, let's do another one. Let's do accurate and precise. precise. So, of course, this one, what would accurate and precise look like? Well, to be accurate, you need to be hitting the bullseye, and to be precise, you need to be hitting the bullseye most of the time, right? All of your darts. So, again, you would have pretty much all of your darts centered around that bullseye. Now, what about poor accuracy, poor precision? So what would this look like? Well, this would be a pretty bad dart thrower, right? Poor accuracy, they're not hitting the bullseye, and poor precision, they're all over the place. So maybe one here, one over here, one down here, and then one up here somewhere. That would be poor accuracy and poor precision. Now, of course, could you do accurate but not precise? That's a little harder to do, but I guess you could. What did I just say? Accurate but not precise. So you could do this one's a little harder. So to be accurate, well, you have to be hitting the bullseye sometimes, but if your precision's bad, that means you're also hitting way far away from the bullseye. So, maybe you're getting something kind of like this, which of course some people would argue, well, that's not very precise. That's not very accurate because, you only hit the bullseye a couple times. So that one's a little bit harder to do. But that's a visual for accuracy and precision and the difference between them. Okay. And that's something that's important to understand. All right. So one more topic, and that is dealing with error. Oh, I'm still in blue. Let me change that. Oh my goodness. Okay. Oh geez, now I'm on, it's just not my day today. Okay, here we go. So what's the idea of error? Okay, so the idea of error is, well, if you're not perfectly accurate, then there's some error associated with your measurement. And that error that we're discussing can be calculated with a very easy formula. Okay? Okay, so if a measurement is not extremely accurate, it contains some error, and that error can be calculated. So let's go back to that idea of temperature, and let's say, let's say that the Weather Channel, we'll go back to the Weather Channel idea, says that it's, whatever I said before, I don't know, I'm making it up now, 82 degrees Fahrenheit outside, but you take a thermometer outside and it says it's 79. Okay. So, of course, the question here is your thermometer accurate? Well, just a couple degrees off, so it seems like it. But is it 100% accurate? Well, no, because it doesn't register exactly what the Weather Channel says. So in this case, because the two temperatures are different, we can calculate something called error. It's a very simple formula. And that formula says error is equal to your experimental value. I should have written this differently because I'm running out of room here. Minus your actual value. Okay, so that was a pretty poor, I'll write it again over here. So the error is your experimental or your measured minus your actual value, okay? So in this case, we could calculate error by saying which one of these numbers is experimental or measured, right? That's the same thing. So the one you measured is this one, the 79. So 79 degrees Fahrenheit minus, which one of these is the actual value or the real value? The weather channel, which was 82 degrees Fahrenheit. And so in this case, I could calculate my error, which is 79 minus 82. Of course, it's going to give us a negative 3 degrees Fahrenheit. That's how easy it is to calculate this idea of error, okay? So in this case, it's negative. Why is it negative? Well, because the actual value was larger than the experimental value, giving us a negative number. Can error ever be positive? Sure, of course, if the experimental value is larger than the actual value, okay? So error can be both positive and negative, and it's this little formula right here, and it's very easy to calculate. Well, last thing is something called percent error, and we use percent error a lot of times in lab experiments. And so percent error looks like this. Oh, just a little more complicated. And that is experimental minus actual, the absolute value, over the actual multiplied by 100. So if we go back to what we were just discussing with the 79 degrees and the 82 degrees, we could calculate a percent error here by plugging in my numbers. So back to that. So let's see, my experimental value was that was the 79, right? So 79 degrees Fahrenheit minus the actual value in that example was 82. The actual value again was 82. Multiplied by 100. And of course, absolute value means that negative sign is going to go away, because the 79 minus 82 is going to give me a negative 3 degrees Fahrenheit divided by my 82 multiplied by 100. But the absolute value is going to take that away. So I need a calculator to do this. Let me get my my calculator real fast. So what I'm essentially doing is just 3, right? Because I'm going to turn that into a positive. So 3 divided by 82 multiplied by 100, and it's going to give me 3.66 percent. Notice my units. Look what happened to my units. Degree Fahrenheit canceled. So of course I'm just in a percentage. So my percent error in this case is 3.66. And one big takeaway from this is that I'm at the end of my thing. Sorry. I'll go up here. So a small percent error equals high accuracy, right? So think about it. Remember, it was 79 versus 82, and I only had a less than 4% error, so that's pretty accurate. And think about if it was exactly 82, right? 82 and 82, well, your percent error would be 0. So the smaller the percent error, the higher the accuracy is in your measurement. Okay, and percent error is something that we'll be discussing and talking about, especially related to lab experiments.